For question 6, part 1, we are just thinking about the particles A and B. So for now we can forget about sphere C. We can just look at A and B. So if we look at before the collision, A is moving, it's 3 meters. It's moving at a velocity u. And then B is moving at a velocity 2u towards it, okay, and its mass 2m. Then after the collision, okay, we're not sure what happens to A yet, but we know that B goes in the opposite direction at velocity u. So currently we're looking for this B. We don't know what direction it is, we don't know what size it is either. So if we take moving to the right to be positive, then we can use the conservation momentum. So we can say that 3mu minus 4mu is equal to 3mv plus 2mu. Okay, so if we just rearrange that, we will have 3mv is then equal to minus 3mu, which means v is just going to come out as minus u. Okay, so it moves at a velocity of minus u meters per second, so obviously we can see it is in the opposite direction to which it was going originally. Okay, it's in the opposite direction. Part 2 is slightly different and asks us to do something else. So part 2, it says that B and C are moving towards each other. C is a mass of 4m, is travelling at u meters per second, and then B collides with C and they coalesce. So they join together when they collide. So we want to find in terms of u the speed of the combined spheres. So before the collision, again split it up into what happens before. So we're going to have B here, which is 2m moving at u meters per second, and then we have got C, which is 4m moving at u meters per second, and then afterwards, okay, we're going to have BC, which is going to be 6m altogether, and we're going to be looking for its velocity, okay, and then from that finding its speed. So again, using the conservation momentum, we can say that 2mu minus 4mu, since it's in the opposite direction, is equal to 6mv. That means minus 2mu equals 6mv, meaning minus mu is 3mv, which means v comes out as just u minus u over 3. So the velocity is minus u over 3, which means the speed, which is just the magnitude of the velocity, is going to be u over 3 meters per second. Part 3 asks us to state whether the combined spheres will collide with A. Okay, so we've now worked out that after the first collision, A is going to move to the left with speed u. Then after the second collision, BC is also going to move to the left with speed u over 3. So because it's only u over 3, it's not going to be enough to catch up with A. So we can say that the combined spheres won't collide with A because it's not travelling fast enough to catch it.